3, 2, 1. Boosters in ignition. And liftoff. We rise together back to the moon and beyond.
For the first time in my lifetime, humans are leaving low Earth orbit and heading back to the moon. In just a few days, NASA will attempt to launch Artemis II, the first crewed lunar mission since Apollo 17 in 1972. For those of you looking for a one-stop shop to get caught up before this historic mission, you're in the right place. We'll talk about the crew, the rocket, the spacecraft, the mission profile, and go over the timelines so you know exactly what to expect for Artemis II. Okay, let's get started. Now before we begin, I wanted to invite you to watch this historic launch live with us in 4K.
Oh, they lit the booster!
I hope you can join us on launch day. Quick side note, all the music in this video comes from my new album, Direct to Orbit, which you can find by searching Everyday Astronaut wherever you stream music, like Spotify or Apple Music, so give it a listen to hype yourself up for this amazing mission. Okay, let's start off by going over the crew of Artemis II. Commander Reed Wiseman is a NASA astronaut and a 27-year Navy veteran and pilot. He flew once to the ISS for Expedition 41 and 42 for 165 days and spent 13 hours as lead spacewalker on 2 spacewalks. Next up, we have Artemis II pilot Victor Glover, who's also a NASA astronaut and former US Navy captain. He flew to the ISS on Expedition 64-65 and was pilot on Crew 1, the first operational Crew Dragon mission. I also met him in 2018, so yeah, I'm pretty stoked to see him fly to the moon. Next up, we have mission specialist Christina Cook, who is also a NASA astronaut. She served as flight engineer on the ISS Expedition 59-16-61. Cook set a record for the longest single spaceflight by a woman with a total of 328 days in space, and participated in the first all-female spacewalk. Last but not least, we have Jeremy Hansen, a mission specialist from the Canadian Space Agency. That's right, for the first time in history, someone from outside of the United States and NASA will be flying to the moon. He was a fighter pilot in the Royal Canadian Air Force and later promoted to colonel. Amazingly, his flight around the moon will be his first spaceflight. You obviously likely noticed that I just listed 4 astronauts, which is an upgrade to the crew of 3 astronauts that Apollo could carry. So let's actually compare the spacecraft and the rockets of the Artemis and the Apollo program. The spacecraft for the Artemis II mission is the Orion spacecraft. Orion is wider at 5 meters wide versus Apollo's 3.9 meters wide, and has about 9 cubic meters of volume versus about 6 cubic meters for Apollo. So it's roomier, like we mentioned, it can carry 4 astronauts, and it even has a toilet. It'll be the first spacecraft to have a toilet outside of low Earth orbit. Orion and its service module is 26.5 tons, making it a little bit lighter than the Apollo command and service module that weighed 28.8 tons. However, because of its small service module compared to Apollo, it can't get into low lunar orbit. We'll talk more about that in a minute. Next, let's take a look at the rocket that they're going to fly on, SLS, or the Space Launch System. This is the most powerful rocket NASA has ever built, with a little over 39 meganewtons of thrust. Most of the thrust at liftoff comes from the 2 space shuttle-derived solid rocket boosters, which provide about 16 meganewtons of thrust each for 32 meganewtons of thrust in total, so about 80% of the liftoff thrust. Then it has 4 RS-25s also taken from the space shuttle program that provide about 7.4 meganewtons of thrust. On the ICPS, or the interim cryogenic propulsion stage, which is its upper stage, it has a single RL-10C2 engine producing a modest 110 kilonewtons of thrust, but it's incredibly efficient at 462 seconds of specific impulse. Let's compare that to the Saturn V, which had 5 massive F1 engines that each produced 6.77 meganewtons of thrust. Then it had the second stage, or the S2, which had 5 J2 engines, and the third stage, or the S4B, had 1 J2 engine. SLS stands 98 meters tall, and its core is 8.5 meters wide and a little over 16 meters wide with its 2 massive solid rocket boosters on the side. The Saturn V stood 111 meters tall and 10 meters wide at the base. Despite having more thrust and more efficient engines on parts of the vehicle, SLS actually has less capability than the Saturn V, as it can only send about 27 tons to the moon, versus the Saturn V, which could throw a whopping 45 tons to the moon. Artemis II will be launching from Kennedy Space Center's LC-39B, which was formerly a Saturn V, Saturn 1B, and Space Shuttle pad. Artemis II is just a flyby of the moon. There will be no landing on the moon for this mission. It's similar to Apollo 8 as a full shakedown of the Orion vehicle, but unlike Apollo 8, it won't orbit the moon. It'll just be on a free return trajectory on a full 10-day mission. It won't be until Artemis 4 until we land on the moon again, and I'm working on a full deep dive video on that and the future of Artemis missions, so stay tuned. During the countdown, there's a few things to pay attention to, so here's a rough overview of the timeline. The rocket will begin prop load at L-9 hours and 25 minutes. Obviously, that's much earlier than other rockets that do a load and go approach, like the Falcon 9. You'll also notice I'm saying L-, which means time until launch, or launch minus, as opposed to terminal count, or T-, which has pauses in the count to allow for built-in holds to review data and transition to other phases of countdown. The ICPS Stage 2 will start prop load at L-7 hours. The crew will start putting on their spacesuits around L-5 hours and 40 minutes, which takes about an hour, after which they'll depart for the pad at L-4 hours and 30 minutes. At L-4 hours, they'll begin to board the Orion spacecraft, and they'll start doing suit leak checks and comms checks. Hatch will close at about L-3 hours and 20 minutes, and from here on, there's additional checks and closeouts. At L-60 minutes, the launch director will hold a brief, so if there's any issues, we'll hear about it then. And at L-45 minutes, the closeout crew will leave the launch pad and get out of the exclusion zone. At L-40 minutes, you'll see the countdown timer hold at T-10 minutes. Now remember, there's a difference between the time until launch, or L-, and the countdown clock, the terminal count, in T-, which is confusing, but don't panic when you see the clock stop at T-10 minutes. At L-16 minutes, the launch director polls the team for the go, no-go poll. At L-10 minutes, the T clock and the L clock will finally line up, and the vehicle is officially in the automated terminal count sequence. At T-8 minutes, the crew access arm will retract. Orion goes on internal power at T-6 minutes, and other systems follow shortly after. At T-33 seconds is the real nail biter. That's the go for the automated launch sequencer.
T-2 seconds.
Go for ALS.
And we are go for ALS.
If you get to that point in the countdown, it's on, but if there were any problems before this, the clock will likely go back to a T-10 minute hold. If a problem arises within that T-33 seconds, expect a full scrub for the day with no further reset as stated in the launch rules. The next thing to look out for is the ignition of the hydrogen burn-off igniters, or the sparkler things, at T-12 seconds, which burn off any hydrogen that is expelled during the startup process of the RS-25s. At T-6.363 seconds, ignition starts on the 4 RS-25 engines, and they'll ramp up to full power over the next few seconds until the moment of truth. Right at T0, the two massive solid rocket boosters ignite and lift off.
2, 1, lift off.
And this is obviously going to be a really exciting moment because we will be watching the first crew to head out to the moon in 54 years. By T+9 seconds, they're already clearing the launch tower, and the rocket will initiate its roll and pitch maneuver. At T+56 seconds, the rocket reaches supersonic speeds, and at T+1 minute and 10 seconds, it reaches maximum aerodynamic pressure, or max Q. At T+2 minutes and 9 seconds, the SRBs burn out and then separate. Then at T+3 minutes and 18 seconds, the launch escape tower will be jettisoned. The crew will ride the giant core stage all the way up until 8 minutes and 3 seconds, which puts them on a highly elliptical trajectory, which is nearly orbital. Then the stage separates and they coast up until T+49 minutes and 49 seconds, when they'll fire up the second stage for the first time for only a few seconds to officially put them into a 2,222 kilometer by 185 kilometer elliptical orbit. Then they basically fall back down to Earth and will perform the major apogee raise burn at T+1 hour and 47 minutes. That would usually be a translunar injection burn at perigee, but for Artemis II, they'll just raise their orbit to be 70,000 km at apogee and 0 km at perigee. This allows for the disposal of the upper stage, and it also means if there's an issue with Orion's service module, they'll be returning back to Earth for re-entry on the next orbit. And here they'll also do a close proximity maneuvering checkout between Orion and the ICPS. Then it takes all the way until T plus 13 hours and 44 minutes for Orion to coast up to that 70,000 km apogee, and there it'll do another perigee raise burn. Then it falls back down to perigee, which takes a while from that altitude. So at T plus 1 day and 1 hour and 37 minutes, Orion will perform its own TLI, or translunar injection, with the service module. Keep in mind when we say T plus 1 day, it's actually day 2 of the mission, since T plus 1 day includes the first 24 hours. At this point, their orbit is now officially raised to do a flyby of the moon. On days 2, 3, 4, and 5, there'll be some tests and things like CPR demonstrations, communications tests, and a handful of correction burns. At T plus 4 days, 21 hours, and 2 minutes, Orion will officially break the record for the furthest from Earth humans have ever been, beating Apollo 13's record of 400,171 kilometers, and will reach a peak distance of about 402,000 kilometers, just barely beating Apollo 13. One important distinction between Artemis 1 and 2 and other Artemis missions is that Artemis 2 is doing a free return trajectory around the moon, and it won't actually get into lunar orbit, or of course, like we said, won't land on the moon either. So after this point, the crew is basically falling back to Earth. At T plus 5 days, 1 hour and 23 minutes, it'll be the closest approach to the moon at about 7,400 kilometers above the lunar surface. On the way back on T plus 6, 7, 8 days, there's a handful of correction burns, there's radiation shielding demonstration, and a manual piloting demonstration. At T plus 9 days, 1 hour and 13 minutes, the crew module and service module will separate, exposing the heat shield of Orion prior to re-entry into Earth's atmosphere. At T plus 9 days, 1 hour and 33 minutes, Orion officially begins its entry interface as it begins to re-enter Earth's atmosphere. From here on out, we'll use altitudes as milestones. At about 11 kilometers, the forward cover will deploy in preparations for the parachutes deploying. At about 8 kilometers, the drogue chutes will deploy, and at about 3 kilometers, the main chutes will deploy. And finally, at about T plus 9 days, 1 hour and 46 minutes, Orion and the crew of Artemis II will splash down and be recovered within 2 hours. Welcome home. So that will complete their 10-day mission around the moon. This will be the furthest that humans have ever traveled from Earth, a mission full of many exciting firsts, and it opens up a new era in 21st century exploration. So that's pretty much everything you need to know about Artemis II. Again, be sure and join us live on launch day, and we'll get into even more details on some of the stuff if you're interested. And I'm also still working on a mega deep dive on the Artemis program as a whole, and trying to figure out if there's any shortcuts or commercial rockets or fast-track lunar lander options that could ensure the US lands on the moon again before 2030. Huge thanks to our Patreon supporters, especially our mission directors, who you can see here on screen. If you want to support the work we do, head on over to patreon.com/everydayastronaut or become a YouTube member or an X subscriber. And just in time for this historic mission, we have some new merch in our shop, including our new orange to the core pocket shirt and mug. That's a nod to the isocyanates that give SLS's core its distinct orange color. We also have some new Translunar Coast and Artemis X Core camo hats, and even this new Translunar Coast shirt featuring the Artemis crew. Pre-orders start now for this exclusive run at everydayastronaut.com/shop. Thanks everybody, that's gonna do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people.